Good afternoon. Welcome to the Talent Arena, where talent meets at the Mobile World Congress in Barcelona, an event organized by Mobile World Capital Barcelona in collaboration with Generalitat de Catalunya, the Barcelona City Council, GSMA, and with the support of CaixaBank Group. Thank you very much for being here. We are delighted to offer during this week many activities to connect talent with the leaders of the sector and in a collaborative environment and continuous professional enrichment. In the upcoming presentation, we will tackle design challenges in large-scale systems, demonstrate troubleshooting techniques, and discover innovative solutions. For this, we are privileged to welcome Carlos Villavieja, staff software engineer at Google. Let's welcome Carlos. Thank you very much.
Yes. Hello. Thank you very much. Can you guys hear me well at the back? Okay, survey. Raise your hand. Español, en castellano? Wow. Okay. Is anybody in the room not able to follow my conversation if I do it in Spanish? Awesome. Okay, it's going to be in English then. Okay. I'm very excited to be here. I'm from Barcelona. I've been living in the US for 13 years. A friend of mine asked me, there's this talent arena. People want to know about what you guys do at Google. Why don't you talk about software engineering? So today I'm going to talk about software trade-offs. Okay, software trade-offs is something that we find every day in our jobs, and sometimes it's invisible to us. So I'm going to give you, several examples, and I'm going to start talking about something to see if we can share some knowledge about what we do. Okay, I'm just a software engineer. I've been working at Google for 10 years. I was raised in Barcelona. I'm a mediocre software developer, but I'm very curious. And my curiosity always brings me success because, I scratch on the systems, I find impact, and, I get promoted, I get paid a salary, and I'm in a very good company. Hopefully, you will see how I understand trade-offs, and hopefully you also learn something about this. Okay, so let's talk about software trade-offs. In Spanish, we say bueno, bonito, and barato. And that's very hard. You want your system to be very fast. You want your users to be happy, but at the same time, your software is evolving. The hardware where you're running is changing. You want it to be cheap. You don't want your system to basically be running on a supercomputer because not everybody has access to a supercomputer. And at the same time, you want bug-free and easy to maintain. Spanish, bueno, bonito, barato. Okay. So what I'm going to try to do is I'm going to build this story of together we're going to build an online system, and let's figure out what are the trade-offs that at every step we need to decide. Okay, so I've decided that the application's requirements for today is we're going to build a hello world. It's a socket-based system. It's all the time returning the same hello. Okay. And the metric that we're going to measure success here is queries per second. How many times can I ask basically the system to return a hello? I'm going to run it in a small Raspberry Pi, and the latest Raspberry Pi has basically 4 CPUs. If you do some measurements, you'll get like 100 queries per second. The two biggest trade-offs or the two biggest things that you need to take into account is the network, because over the network the packets are coming and requesting you for a request, and the compute. Compute is pretty simple. It's just returning hello world. Okay, this is basically how the system should look like. It's a very uniform access, very uniform distribution. Every CPU should be doing around 25 queries per second. Okay, but what's really going on here? We have metrics on the network side. We want fast latency. We want a lot of bandwidth so that we have a lot of requests. And on the compute side, there's some aspects that are interesting. The first one is how many instructions does my processor able to process, and how much parallelism. If you remember the picture before, we have 4 CPUs, so at least I'll have 4 threads, one for every CPU. Okay, but if you look deeper, what I have here is dedicated hardware. I have a Raspberry Pi. It's usually cheap, so I can buy it. Every CPU is running a single thread. You get the network packet, there's an interrupt, the kernel starts, and then the packet is basically delivered to a thread that is exclusively running on that CPU. I don't have to wait for the scheduling. Awesome. Interesting. there's a trade-off here, or there's a characteristic that you need to take into account. I have CPU affinity. My packet is coming from the network. I'm executing all the time in the same CPU, and it's very easy for me to react and respond fast. The working set is also very small. I'm just returning hello world. My code is very simple. Everything is going to be in the cache. That's why we say the cache is hot. The cache is going to be, an access is in the order of 1 to 5 nanoseconds, while if I have to go to memory, I'll probably have to spend 10 to 20 nanoseconds. So it's an order of magnitude faster. Very simple. Okay, conclusions. From the beginning, we need to measure. I know all that data because I use OProfile or some tools that are basically telling me, what is the time on my application being spent. So whenever you're developing a feature for your application, make sure you have some measurements. Something that is going to tell you that besides the functionality, the system is working as intended. Test your metrics. It's useless if you add a metric, the code changes, evolves, and the metric becomes erroneous. You'll think that your system is always working, but maybe the code is already bogus. Anecdote on this. So in one of the companies that I work, we had a very large file system, and at some point a developer said, I need to know when a file was last modified. What he did a stat on the file. That basically goes to the hard drive, which is a very slow operation. All the systems now that were using this functionality had to access the disk. The functionality was very slow, but everybody thought, that's legacy, we accept it. Until somebody debugged it and say, hey, dude, this is in the metadata. We don't have to go to disk. Okay, let's improve our application. Now, besides a hello world, I'm going to basically transform it into a joke. It's a joke service. I'm going to go into the disk, and I'm going to have random jokes, okay? The traffic is still very predictable. I want the jokes to be basically frequently updated. The reason why I want this is because I want some writes into my disk. I'm still going to be using a Raspberry Pi, but now, can I serve 100 queries per second? Probably not, because every single time that I go to disk, at least if it's a hard drive, it's going to be in the order of like 30 milliseconds. The bottleneck is now the hard drive. Okay, this is basically how the system will look like. I'm going to have sequential reads going to the hard drive, and obviously, I'm probably not going to be able to follow the 25 queries per second. Okay, we need to measure. Okay, if we start doing measurements, what we're going to find is that for every request, we're going to see that the CPU is trying to respond with the joke, has to go to disk, so it has to spend 30 milliseconds. You start doing the math. 25 queries per second. In a second, we're going to have 25 requests. That means 40 milliseconds. Now your request is 40 milliseconds of compute and network plus the drive. So now you have a total of 70 milliseconds. And this, if you do the calculation, it's 56 queries per second. So we'll halve, basically, the throughput of our system. Okay, trade-offs. I want to optimize this. I need to think, how do I optimize this? Some of you might think, caching. Caching is a possible solution. But if I just change my hard drive for an SSD, basically I will move from 30 milliseconds to 3 milliseconds. So going to this is kind of going to be like pretty noise. I probably can stay similar to the 25 queries per second. Now, what is the trade-off? We have hard drives. They last long. SSDs are more expensive. SSDs, if you write very frequently, they wear out. They have an internal flash, and at some point, they won't work. So those are basically the trade-offs. At the same time, now that I know that I can optimize my system, I can think every single time that I go to the disk, I can also prefetch. Instead of just grabbing one joke, I can grab 10 or 20 jokes, get them in memory, and then the next time, I don't have to access the disk. Problem. That's optimizing the system. But the first user is going to wait for 70 milliseconds, 40 plus 3, 43 milliseconds, while the rest of them are going to basically have faster latency because the system is caching. Okay, conclusions here. Optimize for what matters. If I optimize the 40 milliseconds of a system that is just returning a string, it's probably going to be very complicated, while the 30 milliseconds is basically low-hanging fruit. Okay? Examples on this. I work on a really large database. Databases need to go to disk. And a developer said, I'm going to solve this. Most of my traffic is read-only. I'm going to put everything in memory. But how much memory? I'll just take some gigabytes. Now the system scales, and basically the guy is caching tons of gigabytes in tons of servers. Money. And at some point, somebody went there, is like, okay, why are you using 2 gigabytes? Well, I mean, I used 2 gigabytes at the beginning and it works. Why change it? Now you build a simulator and we found out there was no reuse access pattern, and with half of the size, he was getting the same success. Same thing for prefetching. What I was telling you before with the joke system. If you're going into the system, reading the disk, and you grab several jokes, that's a very predictable access pattern. Prefetching is useful. But you're going to have users that their access pattern might be randomized, and word prefetching might be just useless. So have metrics that give you what is the success ratio of your prefetchers. How many times do I prefetch a data, and somebody is afterwards using it? Okay, but we've got a CEO, and all of us have a CEO. The CEO wants to grow. He said, we need more jokes. We need 10x more jokes. Okay, so we need basically an scalable solution, This is our design from before, the network, the 4 CPUs, and the disk. Now, we have several options to scale, On the y-axis, we have latency. That's the latency that the customer receives the joke. On the x-axis, we have basically the load. We can say it's the load of the number of requests that we have, but it's also the size of our task. How many threads, how much RAM does it have? And I basically set here 2 lines, the blue line and the red line. As you can see, Raspberry Pi is a low-performance processor, so it's going to have a higher latency. While the red one is basically a new processor, probably a VM that I have in the cloud, that is going to be much faster. And there's 3 modes of operations, 1, 2, 3. I want to be in 1 or 2 because I know my latency is more predictable. My users want their joke in less than 100 milliseconds. While when my system is overloaded, it doesn't matter if I give more RAM or more CPU. It cannot serve more, and basically the latency is exponential. This is what we call basically vertically scaling or scaling up. The other option is we have more than one task serving. And every task could be a different platform. That's why I have different lines with different latencies, or because you're now moving into a VM environment, so your compute is shared with other people in the same CPU. So you're probably going to have interference. And that's why your latency is not going to be so deterministic. That's what we usually call horizontal scaling. Okay, so I'm going to go through horizontal scaling because I think going into the cloud and having VMs seems like cheaper and easier. But now I'm basically duplicating my node. Instead of 4, I have 8. So if I duplicate the node, I basically duplicate the throughput. Not so sure. You're basically doubling your cost. Your hardware, your power consumption, and now we're having a bigger problem because we have 2 disks. So what do we do with the jokes? Are we going to have jokes for Spain here and jokes for the US in here? How are we going to manage this? Okay, so when we do this, basically we have different options. We can basically shard it. There's different jokes. For the service of jokes, we probably don't care. We can have replication. Basically this talk between them, and when you update one of them, there's a lazy update that goes into the other one. If they are located in the same building, probably in the same cluster, you can have a RAID system. So basically, updates are simultaneously done in both of the disks. Okay, we're adding a load balance, so we basically need to consider the trade-offs here. We basically need some new device, some new sort of software that is going to connect the 2 nodes. Okay, the traffic is very uniform, so I say we do round robin. Every single time you get a new request, you just switch to the next node that you want to do. If I want to think about reliability as one of my requirements, I might think, okay, I want each of the nodes to be in a different power domain, in a different outlet. Electricity goes down here, at least I'll have this one, and the load balancer will know, hey, this is working. But there's a trade-off here. You need to talk to somebody, say, I need 2 different power cables here, and that's going to cost you money. And at the same time, we're not going to have the same QPS because there's some time wasted or used for the load balancer to decide, do I go to left or do I go to the right? Okay, conclusions. Scaling horizontal, it's easier, especially in the cloud. You just can click, and you can probably even do automation and get more VMs. It's not the same as going to one of these big companies and say, hey, I want a big server. Oh, it's going to take 3 months. The other one is the more you do component approach, microservices, it's usually easier to grow. Okay? Because you can have, some of the components go into big machines, some of the components go into smaller machines, depending on the compute needs that they have. Anecdote about this. So at Google, I work on memory bandwidth. Okay? When we're talking about load balancing, we think about 2 queues. Okay? I have a queue for food and I have a queue for drinks. And then you basically decide where you want to go. Let's say, sorry, the example is not correct. Let's put food. 2 different restaurants serving the same food. Where do I go? You usually check at the line. Okay? But what you're not checking is what every person in the line is ordering. If this guy is ordering a paella, it might take 30 minutes for me to wait for the paella. But there's only one person. But in here, everybody's waiting for sandwiches. So there was one system that was bottleneck on memory bandwidth. And it was bottleneck on memory bandwidth depending on the request that you were doing. And then when somebody was asking for paella, the system had a lot of compute to do. And then basically, if your load balancer was just looking at the queue size, you would go one people in this line instead of going to 5 people and be much faster. Okay? So whenever you decide that you want to add a load balancer, think very thorough about what are the metrics that you're going to introduce in the load balance to basically do the algorithm of balancing. Okay, CEO wants to grow. We need more features. Now I put my CTO hat. Okay? We're moving into the cloud. The system is growing. I'm getting scared. This is not something that I can manage by myself, so probably the team needs to grow. I'm going to probably need a control version system, and I'm going to need testing. I want that every single new feature that comes doesn't break existing ones. My CEO is not thinking about this. He's only thinking about new features. He wants to grow. He wants business. I need to think that if my system crashes, it doesn't matter all the features that he's providing me. So I got to make some trade-offs. I don't want those features now. I need to basically make my system more robust. At the same time, maintaining hardware is complicated. So it's probably better if one of these vendors that has spare hardware basically can manage my hardware infrastructure. We probably need on-call schedule. You know, what happens if the system breaks when you are sleeping? Well, maybe it might be good to have somebody in another country that can manage basically the system while I'm sleeping. You need to decide between developer work and infrastructure work. Now you're going to have some developers, some SRE, some DevOps that is going to be responsible for releases, monitoring, metrics. The system is growing, and not only the features are important. You know, metrics and tools that allow you to keep the system running become also equally important. And obviously, you know, monitoring. You know, you need to know what's going on in the system. Okay, I'm happy. You know, we moved to the cloud, we have testing, we have monitoring. Life is easy. No, but my CEO is still asking, what about my features? Because he does not see that the system has monitoring, that the system is more robust. He only sees the KPIs of the business. Okay, we got it. I got you. I'm going to transform our joke into a meme generator. The requirements have changed. Now we're going to have a user database because we want to do marketing. We're going to have basically the user providing an input, and basically based on this input, I'm going to call a service. I'm not an expert on AI, but I know there's something that basically can create some images based on a text, and I'm going to use basically an external service. Okay, so this is more or less how my system looks like. I'm still showing you 4 CPUs, but maybe my system is larger. And in the network, I'm basically going to have 2 different systems, a database and the generative AI. Okay, I'm not an expert on databases, but every single time that you confront, oh, my system requires a database, you got to think about something. Do I put a single node versus do I put multiple nodes? If you put a single node, it's very easy. All your data is going to be going into a single node, so concurrency might be a bottleneck, but at the same time, maintenance is easy. At the same time, if you have users in 2 different continents, if you have a single node, the latency for the ones that are remote is going to be large. Another aspect that you need to consider is basically SQL versus not SQL. Traditional databases are very good because they support SQL. You can do joins, but they're usually more slow than non-SQL approaches that basically can store most of the data in memory and usually are faster. You need to decide if you want something that is open or something that is proprietary. Another trade-off that you need to decide. Going into proprietary, you think, oh, I'm getting a better database, but going open might be easier because on-prem, in my office, I can have a server basically and install the same that I have in production. Offline access. What happens with my data scientist? Can he access a terabyte or 2 terabytes of data and do data analysis? How do they download the database? And not least, but important, regional requirements. The law in Spain is completely different from the US. What you store in your database in one of the 2 countries, you need to report it. So you need to take into account when you're designing your system. the generative AI module. This is basically just going to be a third-party component that you're going to use. You need to be very careful when you're choosing your cloud provider. You want a cloud provider that is reliable, but you need to consider what is the failover strategy. What happens when they are not available? Can I replace it? And at the same time, what is the performance? It's very good to test it, but what happens when my QPS are starting to go up? Am I going to be able to pay the bill? Are they going to be reliable? Okay. We're giving the CEO the features that he wants, but obviously, he wants to make more money, and he thinks latency and going faster is key. So he's basically, I want this to be much faster. Okay, trade-offs on optimizing. I put my hat again about CDO, and then I think, okay, I need to spend time developing features versus reducing the latency. Okay, what do I do? Obviously, the CDO wants to develop features, okay, but we've already talked about some of them. But what do I do if I want to reduce the latency? In general, you begin to need some tools. These are basically the tools that I work with: tracers, profilers, and logging. When you have a distributed system, you need introspection. You need to be able to observe what happens when a request arrives and what that time is happening. Remember, optimize for what matters. If you have a trace, you'll be able to see how much time do I spend on the database, how much time do I spend on the generative AI. You will even get insights. Oh, I can do probably the database and the generative AI in parallel, and basically I can short the amount of time that I basically respond to customers. You will be able to identify your critical path. What is the slowest path? What is the slowest component? And you need to identify which is the low-hanging fruit to basically optimize for that. And last but not least, logging. Logging is another way of understanding and having observability. What is my system doing? Okay, last but not least, and I'm pretty sure somebody in the audience has thought about this. We're going to have some memes that are repeated. Barca won the game, Madrid lost, or the opposite. There's a joke in the news or something happening, and people are usually doing very similar jokes. Caching, This is something that I ask on all Google interviews. We design a system, and everybody says, oh, I want a cache. It's like, okay, but what are you going to optimize? Be very careful when you add a cache, because it's a trivial idea to add into a system, but it's very complicated to optimize it well. You need to think about, okay, I cache a joke, but that joke has a time to live. If you put a joke in the cache, it's wasting memory and nobody uses. That's basically memory that you're spending that you don't need. And again, invalidation of caches. If you are serving news and you're caching news that are not used, you might basically serve inconsistencies. Imagine there was a bug in the news, the reporter added in the newspaper, your system caches, you fix it, but you do not invalidate that entry. Your newspaper website is still reporting about news. Okay, yeah, but our CEO, he still wants to grow. He wants to go worldwide, okay? Considerations that we need to think when we are going multi-region. And I work in a place where we have lots of data centers. Scaling from 1 to 2 is a nightmare. From 2 to n, it's the same thing. Okay? First thing, you need to set up a load balancing strategy. Most of the time, you're going to go for the trivial way, which is the IP address of my customer is telling me where he's located, and I'm basically going to redirect the traffic there, because that way he's going to get lower latency. Some users use VPN. They are telling me that they are in Spain, but they're in the US. Your load balancer might not know this. When you're doing this, think about the failover strategy. At some point, my Spain data center is going to fall. And then I want my system to basically detect this immediately. My DNS update needs to be very fast so that I can fail over to the US. And my US needs to be sized, and my Spain, so that at some point they can increase on a keep. They can manage that spike on load that I'm going to have. Because otherwise, just don't set the failover. If Spain goes down, you leave Spain go down. You don't want a cascade effect that basically the US users start failing. The damage control that you need to do here is important. Okay? When you are basically having several regions, you're going to have databases where you have a leader and a follower. The leader is usually the user that is going to, the entity of the database instance that has right accesses. It's the one that is going to write, while the follower might have stale information. But for many businesses, that is not stale information. That is just not updated. If you need consistency, you're going to have to do locking between different regions, and consistency and consensus, which are usually pretty complicated. So you want to avoid that. And last but not least, releases. When you are just having a region, just having a Raspberry Pi, you do a software change, you build your release, and you deploy. That's all you need to do. Immediately you know if it fails or not. Now, when we are talking about services that are worldwide, we basically need to pipeline. We do canary. We deploy our release into one data center. The canary is basically telling me that it's working as intended, and then I make progress in my pipeline. The fact that one instance of one region works does not mean that all of the regions are going to work, because there's going to be one user doing one access pattern in one of your regions that might be the one that detects your failure. So that's why you continuously do it pipeline, okay? And you make sure that your releases are also rollback compatible. Okay, and the coffee to finish. I've talked really fast. I've talked a lot of things, but these are the 3 things that I want you to remember, okay? Your system continuously changes all the time, okay? If your software doesn't change, at some point it's going to be deprecated and you're going to throw it away, okay? You need to add metrics. You need to add metrics that not tell you about the business, but tell you about the performance, about the reliability, about if a binary is running or not. And when you are doing a code review to one of your colleagues and he's adding that metric, you don't say, hey, well done. No, you tell them, what's the testing? How do I know that somebody else is not going to change my algorithm and the metric is still going to be showing me values from the old implementation? Because if you don't do that, at some point the metric becomes stale, becomes useless. Second of all, the importance of understanding the trade-offs. It's not only that I know that I'm serving jokes. I know how much compute I'm doing. I know how much network I'm doing. Knowing those facts, I can talk to the CEO and I know where I have to spend money. What is the next step for us to scale? What do I need to optimize? Obviously, you've added metrics. Now, it's very easy. You add monitoring. Monitoring is going to give you, real-time information about what the system is doing. And alerting is going to wake you up when the system is broken. Or it's going to page, somebody else that is on call. And last, usually I see people wanting to do the latest, most fancy technologies. Perhaps subscribe, AI, latest database. And most of the time, it's not needed. Most of the times what happens is what we want to optimize too early. Think about this. What do you prefer, to have the fanciest system that breaks continuously, or the more stable system that basically is helping your business? Thank you. Do we have time for questions, or should I do them later? 4 minutes? Okay. Si alguno quiere preguntar en castellano, podéis preguntar en castellano y yo luego traduzco. I haven't seen anyone raise hands, so. Come on, don't be shy.
So, in English, I guess. So, you briefly mentioned monitoring and alerting, and I find it's very difficult, and it's always attacked at the end. It's only like when problems happen, people start thinking, oh, why didn't we know, and start implementing monitoring, after they have a very large code base. How would you advise to address this? Obviously, it should have done before, but if it was never implemented, how would you advise to do it?
So, in the systems that I've designed from scratch, I basically think about how is the system going to fail. And many times, we basically have an outage, a failure, and we realize, oh, we didn't have that metric. Now we need to add. So it's basically an iterative process. When I go into a team, where it's a new team, they have a legacy system, I start asking, okay, how is the system working? How do I know that the system is working? And then basically I start creating back tickets to my team. It's like, hey, I see all these flaws. You know, who is basically going to show me this? And then you get people that teach you, no, we know this through this other metric. So it's usually an iterative process. And even at Google it happens. You know, we deploy a system, and then 3 months after we've been running, it's like, okay, who did this feature? Why don't we have, you know, this other metric? But you basically keep iterating, and as you have improvement in features, you improve your monitoring. Okay? You add and add and add. I would say that if I go to a new company, I usually start with the basics. You know, are my binaries running? You know, all the binaries at Google by default have a metric. Just when you compile the binary, by default, a library is linked, and the metric is called presence. And the minute that you have a binary deployed in the system, and the metric presence is not reported, there's an alert. Okay? But that's for default, by default. So I would think if I'm doing basically, you know, microservices, all my binaries need something that tells me the binary is not running. Okay? Now, if at some point I have an entrance of queries from users, I want to know about that metric. Not even me as CEO, as a technical person. The CEO wants, hey, how many queries am I having? Because I want to sell my company, or I want to go to customers and say, we support this amount of queries. So that's something that you're going to be asked from the business side. Good? Okay. Any other questions? Somebody over there at the end.
Buenas tardes. ¿Cómo hiciste para entrar a trabajar con Google?
Uf, mucha suerte, porque con lo tontito que soy. Bueno, yo estudié en Barcelona la carrera, fui a trabajar a la...
¿Qué carrera?
Ingeniería informática en La Salle. De allí monté una empresa, no me llevaba muy bien con mis socios, lo dejé y dije, voy a hacer investigación. Me fui a la UPC, hice un doctorado y yo le dije a mis padres, yo me quiero ir a Estados Unidos, yo me quiero ir a Estados Unidos. Y encontré una beca y me fui a trabajar con un señor en Estados Unidos porque yo quería ser profesor de universidad, pero en un momento dado dije, me quiero ir a la industria. Y estando en una universidad americana como becario postdoc, apliqué a varias empresas, cogí todos los libros de entrenamiento de algoritmos y demás y hice entrevistas y entré. Pero se habla mucho de que las entrevistas son muy complicadas y que la gente se tiene que preparar. Piénsalo como aquí en España hablaríamos de una oposición.
Muchas gracias.
De nada. Okay. We're gonna have a workshop afterwards. I think we're run out of time. Please keep the question and ask me later. Okay? Thank you.